Hello everyone, and welcome to today's episode of our Cardcast. Today is June 1st, Monday, 2026. I am your host, ichino-ani, and I am so excited to be here with you today. Are you all ready to learn something super cool today? Well, gather around, because we are going to dive into a brand new paper from the world of machine learning. It is always so magical to see what computers can do when we teach them properly. Today, we are looking at a paper whose title is SchGen, Schematic Generation with Semantic Grounded Code Representations. The curl is chatskon/arxiv.org/abs/3605.30,345 Yes, it is quite a mouthful, but do not worry. I'm going to break it all down for you, just like we do in our fun science classes. So what is this paper all about? And let us start by talking about printed circuit boards, or PALs for short. We know those little green boards inside your toys, computers and phones. The ones with all the tiny little metal lines and black squares? Right. Those are PCBs. They are the brains and nervous systems of almost every electronic device we use. But here is the tricky part. Designing a blueprint for these boards, which we call a schematic, is still mostly done by hand. Engineers have to sit at their computers, pick out every single component, and draw lines to connect them all together. It takes a lot of time. You need to be very smart and know exactly what you are doing. Now you might be thinking, why do we not just ask an artificial intelligence to do it? Well, that is the exact problem this paper is trying to solve. You see, large language models, like the ones that can read stories or chat with you, have gotten really good at writing software code. But when it comes to drawing hardware schematics, they get very confused. Why? Because the files that save these schematics are incredibly messy. They are full of tool-specific formatting, verbose metadata, and absolute geometric coordinates. Imagine trying to build a Lego castle, but the instructions only give you the exact millimeter measurements of where every block should be on the table. Instead of just saying put this block on top block, that would be super hard, right? That is how the AI feels. Smart researchers from SchGen, Legal, and Microsoft Research came up with a brilliant idea. Instead of forcing the AI to read those messy, geometry-heavy files, or trying to make it draw an image, they invented a new way to represent the schematics. They created a Semantic Grounded Code Representation. That means they turned the process of drawing a schematic into simple, easy-to-understand Python code. Instead of absolute coordinates, they use relative placement. So the code just says, place this resistor next to that lid. And instead of drawing the lines between exact prints on the screen, the code says, connect the power pin of this chip to the power pin of that resistor. This turns a very complicated geometry problem into a simple logic problem, which language models are really good at solving. And to train a new AI, which they call SchGen, they needed a lot of examples. But there were no big datasets of these code representations. So that's a clever pipeline that takes open source hardware designs from the internet, fixes them up with the help of a human, and translates them into this new, beautiful code format. Then they trained a 20 billion parameter model on this dataset, and guess what? It worked amazingly well when they tested SchGen. It completely outperformed much with DET 5.2 in making valid, working circuits. It achieved an 82% valid circuit rate. That means it followed all the rules of electronics perfectly most of the time. When experts looked at the circuits, they found that over 60% were completely functionally correct, compared to other technologies that just try to use raw text files, which only worked about 3% of the time. This is a huge leap forward. Now let us imagine how this amazing technology could be applied to our everyday lives. I have 3 super fun examples to share with you. First, let us think about rapid prototyping for inventors and makers. Imagine you have a great idea for a new smart collar for your dog. Normally, you would have to hire an expensive electrical engineer to design the circuit board. But with SchGen, you could just type into your computer, I want a circuit board with a GPS tracker, a battery, and a Bluetooth module, and boom. The AI generates a perfect, editable schematic for you. This would make it so much easier and faster for people to bring their cool inventions to life. Second, think about smart home gadgets. Right now, companies make one-size-fits-all devices. But what if you wanted a custom sensor that detects when your cat is at the door? It also measures the temperature. With this AI, Companies could automatically generate custom circuit board designs on the fly based on exactly what a customer asks for online. You could order a completely personalized electronic device, and the factory could pick the board the very next day. This could be a fantastic educational tool for students. Just like you all learn in school, sometimes electronics can be really hard to understand. If a student is learning how to build circuits, they could use SchGen as a smart tutor. They could type, "Show me how to wire a blinking lead with a 9-volt battery," and the AI would generate the exact, clean schematic code. The student would read the code, see the relative placements, and easily understand how the components interact. It would make learning hardware design as easy as learning how to bake a cake. It is just so wonderful to think about how AI is learning to build the physical things we use every day. By translating complex visual and geometric tasks into semantic, meaning-based language, we can unlock so much potential. It really shows that sometimes the secret to solving a hard problem is just finding the right way to explain it to the computer. I hope you enjoyed learning about SchGen today. It is always a joy to explore these big ideas with all of you. Remember, every big invention starts with a simple schematic. Thank you so much for listening, and I will see you next time for more exciting discoveries.